This is Professor Pelton. This is part 3 of chapter 5, section 5. So what we saw in the last part is if you have irrational answers, you don't have one of them, you have two of them, because you either have to solve and do a square root and get plus or minus, or you do a quadratic formula and get plus or minus. Therefore, if a plus root b exists, a minus root b must also exist. And if a plus root b exists, a minus, then a plus root b must exist. So you can't just have one, you have to have both, essentially. So now we're going to work from the other perspective. What if I gave you the zeros? Could you give me the function? That's what we're going to do. Okay, so we scroll all the way down here. So the least degree polynomial is what I'm going to say, because these could be in multiplicity, which means they could happen more than once. So we're just going to assume they happen once. So this function is going to have some constant a, and then x minus 3, and then x plus 1. Because if I solve those, I will get the 3 and the negative 1 for the zeros. Then I have a irrational 0. So I have x minus 2 plus root 5, but I can't just have that one, it's impossible. So I must have also had x minus 2 minus root 5. I had to have had that as an answer, because if I do the quadratic formula, I would have gotten both. That's the only way you're going to get two irrational answers. Okay. All right, so I'm going to combine the, don't just go left or right on these, that'd be very difficult. Combine the like factors. So x squared plus 1x minus 3x minus 3. And then here I have x minus 2 minus root 5, and then x minus 2 plus root 5. Okay, so that gives me f of x equals a, x squared minus 2x minus 3. Okay, so notice when I multiply the next one, it's 3 things, or 3 terms times 3 terms should give me 9 terms, right? So if I go through, I get x squared minus 2x plus root 5x, right? So I go through and then do the negative 2 next. So negative 2x plus 4 minus 2 root 5. And then going through the next of the root 5 minus root 5x. Oops, I didn't put the 5 in front. Root 5x, there we go. And then we have plus 2 root 5, and then minus root 25. All right, so that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. And what you'll notice if you look closely in the list, a lot of these will cancel each other. Those x's cancel, and those cancel. Okay, so if I simplify the list of what I have here, I have f of x equals a, x squared minus 2x minus 3. So this gives me x squared minus 4x. Right? You notice that this is a 4, and this is actually minus 5, so I get minus 1 is my constant. Okay, so I'm going to multiply those two trinomials now. Okay, so that gives me x to the 4th, right, when I go this way. And then minus 4 x to the 3rd, and then minus 1x squared. Then I'll do the negative 2x next. I did that one. I'm going to do this one. So that's negative 2x to the 3rd plus 8x squared, and then plus 2x. Now I'm going to do the negative 3. So that's negative 3x squared, and then plus 12x. And then 3 times 1 gives me 3. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 3 gave me 9 terms. So f of x equals a. So I have x to the 4th. That's a bad a. Let me make a better a than that. Okay, so if I do the 3rd, I have minus 4, minus 3, and minus 3. No, I'm sorry. Minus 4 and minus 2 is minus 6. If I look at the second power, I have 1, 8 minus 3, so that's plus 4, right? And if I look at the x's, I have 12 and 2 for 14. and then a plus 3 on the end. Okay, so that looks like our simplified form. All right, so I need a coordinate now to figure out what the a value is. Because there are an infinite number of functions that will go through these zeros, we need to know the specific function. So we have this coordinate right here. If you plug in 1 for the x, you can get 32 for the y. So 32 equals a. And if I plug in 1, I'll get 1 minus 6 plus 4 plus 14 plus 3. So I get 32 equals a times, that's going to be what, 16? So a equals 2. All right, so I'm going to take that and plug it into there to get the actual function. So the actual function, if I plug it into there, 2 all the way through gives me 2x to the 4th minus 12x to the 3rd plus 8x squared plus 28x plus 6. All right, so that's the actual function. So we went backwards before. Instead of taking a function and breaking it up into zeros, we took the zeros and made the actual function. All right, pause the video. Try the student problem for yourself. Okay, so let's write the function down. So f of x equals some value a, and then x plus 4, and then x minus 1 will give us the values that we have here, right? Okay. All right, so then we have our zeros. So we have x minus 1 minus root 5. And by the conjugate theorem, we should have x minus 1 plus root 5 also. It is impossible for only one to exist. They both have to exist. So there are an infinite number of functions that go through these zeros, but the factor of a will differentiate to be the specific function we're talking about. All right, so f of x equals a. So don't go left to right. Just combine the common or the similar factors first. This is x squared minus 1x plus 4x minus 4. And over here we have x minus 1 plus root 5 and x minus 1 minus root 5. Okay, so f of x equals ax squared plus 3x minus 4. And then 3 terms times 3 terms should give me 9 terms, right? So x, starting with the x, that gives me x squared minus 1x minus root 5x. And then the negative 1 gives me minus 1x plus 1 and then plus 1 root 5. Okay, and the next one, root 5, so plus root 5x minus 1 root 5 and then minus root 25. Okay, so that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. 3 times 3 gives me 9 terms, right? And I can cancel a bunch of these, like that one cancels that one, and then that one cancels that one, correct? So we're left with a lot less terms now, which is why you want to combine the similar ones first, so you don't have to go through the mess of not having it cancel. So x squared plus 3x minus 4. So this gives me x squared minus 2x. And then this is 1, and that's going to be minus 5, so that's going to be a minus 4. Okay, so 2 trinomials, 3 and 3, is going to give me 9 terms. Okay, so if I start with this, I get x to the 4th minus 2x to the 3rd, and then minus 4x squared, right? Because essentially I'm just going like this, right? When I multiply. So I'm going to do the 3x, I get 3x to the 3rd minus 6x squared minus 12x. Okay, and then the last one minus 4. So minus 4x squared plus 8x. And then plus 16. Okay, so we simplify that. So f of x equals a. f of x equals a. So x to the fourth. So if I look at the thirds, I have 3 minus 2, so that's 1x to the third, right? So plus 1x to the third. If I look at square root, I have minus 4, minus 6, and minus 4, so that's minus 14. So minus 12 and plus 8 says minus 4x. And then plus 16 on the end. Okay, so now we need to know what specific function this is. We need a coordinate. So this is the coordinate that's given. Okay, so we're going to say 18 equals a. So if I plug in a negative 1, I'm going to positive 1. If I plug in a negative 1, I'm going to get 1 times negative 1. If I plug in a negative 1, I'm going to get a positive 1. And if I plug in a negative 1, I'm going to get a negative 1. Okay, so that's 1 minus 1 minus 14 plus 4 plus 16. So 16 plus 4 is 20. Minus 14, so that's 6. So 18 equals a times 6, or a equals 3. So we're going to take that, plug it back into there. Okay, so we plug that back into there. F of x Okay, so times 3 is 3x to the fourth. Times 3 is 3x to the third. Minus 52x squared. Minus 12x plus 48. Okay. All right, let's go to the next page. Talk about the fundamental theorem of algebra. Okay, so to this point, all of the answers we've gotten have been either rational or irrational, but the reality is they can fall within the complex number system. So you could get imaginary answers, because when you do the quadratic formula, you could get 2 imaginary answers, but there has to be at least 1 in the set of complex numbers. And the corollary of that is if the polynomial is degree n, where n is greater than 0, obviously, because it's a polynomial. If you set it equal to 0, it has exactly n solutions, thus that many zeros. So if you look at this equation here for a, how many solutions does it have? 3. Those solutions might be real or imaginary. They might be rational or irrational. We don't know in the real. We have to solve that out. So the next one, how many zeros are there? There's going to be 4. Okay, those zeros might be real or imaginary, rational or irrational. Who knows? Okay, how many solutions does this equation have? Well, 4, right? How many zeros does this one have? Well, it has 3. Okay, so zeros meaning you set it equal to 0. That's the x-intercepts, or just simply the solutions, and you solve the equation. Okay. All right, so let's look at some cases where perhaps the answers are not all real, but still in the complex number system. Okay, so in this case, my p-value is constant of 8, and the q-value is a 1, right? So we got a 1 here. Okay, so the factors of 8 are 1, 2, 4, and 8, and the factors of q are simply just 1, so the list is not too bad this time. So it's 1 over 1, 2 over 1, 4 over 1, and 8 over 1. All right, so if you look at a calculator, it looks like it goes through -1 and bounces off. So I'm going to do the -1. So I have 1, 0, 1, -2, -12, and -8. And you're like, well, wait a minute, there's no 0 in the original problem. But if you look, there's no fourth power here, right? So just like we did division, we had to put in the zeros in the prior section. For synthetic, it did the same thing. You have to put in the zeros for the missing terms. Okay, so I'm going to add, then I'm going to multiply by -1. I'm going to add, I'm going to multiply by -1. I'm going to add, I'm going to multiply by -1. I'm going to add, I'm going to multiply by -1. I'm going to add, I'm going to multiply by -1, and it works. So I get f of x equals x plus 1, 1x minus 1x plus 2x minus 4x minus 8. So the original problem was a fifth. So this is 4, 3, 2, and 1. Okay, so notice on the graph that it bounced off, right? Remember, if it bounces off, it's multiplicity 2, okay, or even. So I'm going to try negative 1 again, since when I looked at the graph, that's what it was. So 1, 0. I'm sorry, negative 1. I apologize. Looking at the wrong spot here. Negative 1, 2, negative 4, negative 8. All right, so I'm going to add, multiply by negative 1, add, multiply by negative 1. I'm going to add, multiply by negative 1. I'm going to add, then multiply by negative 1. And it worked. I was right. Okay, so I get f of x equals x plus 1, and I get another x plus 1. So I was right, it bounced off, so it's multiplicity, and it happens an even number of times. So I have 1x minus 2x plus 4x minus 8. Since the one I just did was fourth power, then this one is 3, 2, and 1. Okay, then I notice on the graph that it goes through 2. Okay, so I'm going to try 2. So the values I left off with are 1, negative 2, 4, negative 8. 1, negative 2, 4, and negative 8. So I'm going to add, multiply by 2. I'm going to add, multiply by 2. I'm going to add, and then multiply by 2. It looks like it worked. Okay, so my function is I have x plus 1 twice. So it bounces off the x-axis. And then x minus 2 will give me a 2. And then 1x plus 0x plus 4. So the prior problem, I left off with a third power. So now I'm down to 2, 1, and 0. Okay. Well, here's the problem. If I do the factors of 1 and 4, I get 4, which is 1 and 4, 2 and 2. Or negative 1 and negative 4, or negative 2 and negative 2. None of those give me 0, so it means it's not factorable. So if I set this equal to 0, okay, and I'd solve this term individually, I'm going to get x squared equals negative 4, or if I square root, x equals plus or minus root negative 4, which is plus or minus 2i, isn't it? Because it's imaginary, take the negative 1 out. So 0 equals x plus 1 squared, x minus 2, and then x minus 2i and x plus 2i are the actual factors, right? So there's the factors, right? So the zeros are x equals negative 1, 2, 2i, and negative 2i. Okay, that is the end of part 3.